All right, so we have a couple more examples to deal with these simplifying expressions. The thing with simplifying expressions that gets tricky is that there's not always one way to simplify, as you can kind of see. We're going to be relying on a lot of our algebra skills to translate into our trig skills and simplify these things using those identities. So example 6 says to distribute the terms and simplify. So if I take the cosine plus sine and square it, that is not the same as cosine squared plus sine squared, unfortunately. What that means is you're going to take cosine of theta plus sine of theta, and you are going to multiply it by itself. Then distributing, sometimes called foiling as a little acronym to remember things, but we're going to take cosine times cosine, which will become cosine squared. So the first, the outside, the inside, and the last. Sine times sine will get you sine squared. So you might be wondering, Ms. Schwartz, why did you color code these things? Well, I'm trying to help you see some identities you can then use. Cosine squared plus sine squared is a Pythagorean identity that gets you 1. So I've used up those, and they added together to be 1. Now these ones in green, I have a sine cosine and another sine cosine, which are like terms. So if I add those together, I have 2 sine thetas times cosine thetas. There is your simplified answer. Now, you might be saying, Ms. Schwartz, you just wrote down more letters than you did up here. And I agree, but having this function inside of a squaring function is harder to work with than just having 1 plus twice these 2 functions, sine and cosine. All right, example 7 says split a fraction into 2 that can be multiplied. This is going to be one that you use often. So cotangent of theta divided by cosecant of theta is not something that just nicely cancels itself out. So instead, I can think about this as cotangent of theta over 1 times 1 over cosecant of theta. Because if you put those right back together, cotangent times 1 is, well, cotangent, and 1 times cosecant is cosecant. Now, the reason why that helps me out is I can use some identities. I know that cotangent of theta and cosecant, I could use my sines and cosines. So cosine of theta over sine of theta times 1 over cosecant is the same thing as sine of theta. Now sine is going to cancel out, and I'm going to be left with cosine of theta. Now the thing is, you could have changed cotangent to be 1 over tangent, but 1 over tangent doesn't help anything cancel with cosecant. Right? You're trying to get things to cancel out, so you want to use multiple identities that relate with each other, which oftentimes will incorporate sine and cosine. All right, number 8, split one fraction into several being added or subtracted. So you'll notice that we have a monomial, a single term in the denominator here. And having one single thing in the denominator without addition or subtraction, it's okay if you've got multiplication, but no addition or subtraction, means that I can split this up into a bunch of different fractions that would have been added together. So I'm going to do cosine over sine plus sine over sine minus sine cubed over sine. You can check your work, because if you added these right back, you would get cosine plus sine minus sine cubed all over that same denominator of sine. Now we're going to use some identities. So cosine over sine, that's going to be cotangent. Sine over sine is going to cancel to just 1. And then sine cubed over sine is going to be sine squared. Well, from a previous example, hopefully you identify 1 minus sine squared. That's the same thing as cosine squared from the Pythagorean identities. And then this one's just going to be cotangent. That's as simple as it's going to get. And there's your final answer. All right, so number 9 gets to that concept that I said where you're trying to relate these things using multiple identities, and sine and cosine is going to be a common thread through them. So if you really are completely stuck and you don't know what to do, I would start by splitting up fractions as much as possible, and then I would use sines and cosines. Okay, if you're not sure how to relate things to each other, sines and cosines are a great way to go. So I'm going to start by doing cotangent of theta over 1 times 1 over cosecant theta, just like I had on the last one. And then this one will become tangent of theta over 1 times 1 over secant of theta. So I'm just splitting up those fractions. Using identities then, cotangent becomes cosine over sine. I remember that one because co comes first. Cotangent has cosine in the numerator. 1 over cosecant is the reciprocal of sine. Tangent, well, it's not the reciprocal. Cosecant is the reciprocal of sine. So 1 over cosecant gets you back to sine. Tangent is sine over cosine because it's y over x, opposite over adjacent. And 1 over secant is the reciprocal of cosine. So dividing by secant is the same thing as multiplying by cosine. And look at all this stuff that's going to cancel sine and sine. And I'm left with cosine, cosine and cosine, and I'm left with sine. Now, this looks kind of like a Pythagorean identity. You've got cosine and sine being added together. But if you remember from the algebra review video, Pythagorean identities only work if you had squares on these. Okay, because Pythagorean identity is a squared plus b squared equals c squared. So the fact that this is just cosine and sine, that's where we're going to have to leave it. All right, so you have, it says even more practice problems and then simplify each expression. So I want you to pause this video and I want you to try those 3 problems either by yourself or with a partner, and then come back and check the video to get the answers and get the final summary of the lesson. So go ahead and pause your video, take a minute or 2 to work on these next 3 problems, and then come back when you're ready. All right, and they just started a drill this morning. You can hear that lovely buzzing. So I'm going to pause this and come back in just a moment. All right, we're going to go with it, and hopefully that doesn't happen again. If it does, I will pause and pick up when I can. So this one is factor and simplify, but actually when you factor this using your algebra skills, it doesn't simplify anymore. 2 sine x plus 1 and sine x plus 1, neither one of those are going to be nicely replaced with an identity. So that's where we're at, just factoring a little practice of algebra. These next 2, you're going to want to use the quotient identity for tangent and then cancel out some cosines. Then you're going to use a reciprocal identity for secant and cancel out cosines again. So just some final notes. You might want to jot these down somewhere if you have room in your notes. The squares must be on your Pythagorean theorem. So sine squared plus cosine squared definitely equals 1. But sine plus cosine does not equal 1. Does not equal 1. Because what's happening there is kind of like the example from the connection video. We know that 3 squared plus 4 squared is equal to 5 squared, right? Because 9 plus 16 is 25, 3, 4, 5 triangles, etc., etc. But when you try to go from this line to this line, what you're doing is you're saying, I'm going to just say that 3 plus 4 is equal to 5. Well, that's definitely not true. So, have to have the squares in order for Pythagorean theorem to work. But then the squares on the reciprocals or the quotients can continue throughout the problem. If we know that tangent is equal to sine over cosine, if I square tangent, that's the same thing as squaring this whole fraction, which would be squaring the top and squaring the bottom. So that's okay. All right, no more signals going off. Don't know if you heard that. And then same thing would be true if I had tangent cubed. This would be cubed, and then this would be cubed and cubed. So just something to consider as you're going through and simplifying. These take practice. Practice, practice, practice. The worst thing that happens is your problem gets messier before it gets cleaner. But as long as you are making legal substitutions with your reference sheet and your identities, things will come out just fine, okay? Don't let your algebra be the reason that your trig doesn't go well.